Thanks for tuning in at Brackies.
Hello everyone and welcome to video number 6 on making a multiplayer FPS in Unity. In this video we'll finally do some shooting. So we're not going to be doing the graphics for the shooting, and we're not going to be doing any damaging of the players either, but we are going to get the actual shooting mechanic in place. So we'll create a system for registering input, firing out a ray, doing some collision checking with layer masks, and finally we'll notify the server that a player has been hit, so that the server can send out a debug.log statement saying that this player has been hit to all clients. So that's kind of how far I hope to get today. And before we get started, I of course want to mention that you can get the full project folder with all of the previous versions on GitHub, links in the description. And also if you have any questions and can't get that to work, well then I suggest you visit the Brackies forum. So let's get started. So let's start by making a PlayerShoot script. So let's select our player, hit add component, and type in PlayerShoot and simply create that. And we can then double click it to open it up in Visual Studio. And also I want to go into the project panel here and create another script, which is going to be the player weapon script. And this is simply going to be a fairly empty class. It's just going to store a couple of members that will host information about our weapon, at least for now. So let's double click that too. And now we should have these two. So in the PlayerShoot script here, instead of using system.collections, we want to be using Unity engine.networking, and of course want to derive from network behavior, as we've done with any networked object. And I simply want to delete all of this. And the first thing we want is basically a reference to our player camera. Because when we are shooting a ray, we want it to shoot from the exact center of the camera. And therefore, we need a reference to it. So let's make this a serialized field so we can make it private, but still drag something into it in the inspector. And it's going to be a private camera, and we'll just call this cam. And just to make sure that we've actually inserted a cam into this slot, we'll just check in the start function if cam is equal to null. And if it is, well then we want to throw an error. So debug.log error. And we want to just say no camera referenced. And we can maybe just tell ourselves that it's the PlayerShoot component saying this. And then we can simply disable the component. There we go. Then of course we want our current weapon, and at some point we want to do some weapon swapping, and also a way to swap the graphics of the weapon. But for now our player weapon class will simply store stuff like damage. So we need a public, and we'll just make this public for now so that we can access it in other scripts. And this is going to be a public player weapon, and we'll just call this weapon. And simply close that off. We'll fill in the values in the inspector. Then we can hop into our player weapon component here and remove the system.collections namespace and make sure it doesn't derive from anything. This way we have a standard public class. Inside of this public class, we want to create a few members. So the first one is going to be a public string, and this will store the name of our weapon. And we could make this a charged laser or a more modern name. We'll just call this a Glock. And I'm sorry, but I don't know any model names for Glocks. I'm sure that there are so many different ones, but this will do for now. The weapon fanatics are probably going to call me out on that. So then we're going to have a public float storing the damage. You can make that an integer if you want, but I like to have have full control over that. And a public float storing the range, and we'll just default that to 200. So that's quite a long range here. Changed my mind. Good. And of course we can do stuff like fire rate, whether it's single fire or burst, and we can do shotgun stuff and all of that. And we'll definitely have a look at some of that stuff at least later. But for now, this is all we're going to need. So let's save that, head into the player. Oh, I forgot one important detail, and this is very important. We need to tag this class as a system.serializable class. So this class needs to be serializable, because what that means is Unity will know how to save and load this class, and that way we can change these values in the inspector. If we don't tag this as a serializable class, we won't be able, it won't even show up as a variable in the inspector. So that's very important when dealing with classes in Unity. So next up, let's create the update method here. So void update, and in here we simply want to check if we've gotten some input. So if input.get button, and for now we'll do get button down. So this is a single fire weapon, and the button that we want to check for is the fire 1, and this is again one of those default inputs as defined in Unity. And actually I want to change this a bit. So if we go under edit, project settings, and then input, you can see the fire 1 input here, and you can see that it has this positive button left control, and I think that's super annoying. So let's remove that so we don't shoot whenever we press control. We simply want to be able to shoot using the mouse key, and we of course want this to be key or mouse button. Cool. Then we can head back into Visual Studio, and if we get this button down, well, then we want to call some kind of shoot, oops, not player shoot, some kind of shoot method. Go away. Here. And I think it's time to go ahead and make that now. And this is just going to be a private method, of course, called shoot, and it's not going to take any arguments. And this is where we do our actual raycast. So let's start by making a private raycast hit. I will just call this hit. And we want to make this variable because the way Unity raycasting works is that we send out a ray by calling a method, and we have this out variable. And what this means is that we define this raycast hit, we declare this here, and then we put it in as an argument to the function. And the function will then fill out information into this variable. So basically the hit variable here will store information about what we've hit, and a lot of other stuff, where we hit it and all that. So now we can simply say that if physics dot raycast, so if we hit something with the ray that we're going to be shooting here, then this logic here will be called. So we hit something. So shooting in rays in Unity is quite a bit of syntax actually. So if physics.raycast, and then we want to define the start of our ray, and that is going to be our cam.transform.position. That's a vector 3 of the position of the camera. Then we want to have the direction. You can see just how many overloads this has. So we want the direction that we want to shoot in, and that is going to be cam.transform.forward. Then we want to input, I think it's time to input either the max distance or out the hit. I think it's out hit. Then the distance, and the distance here is going to be weapon.range. And finally, we want some kind of layer mask. So we'll define that up here. So basically, when we're shooting out a ray, we want to be able to control what the ray will hit. So we only want this to be able to hit objects that we can actually see, not visible invisible colliders or anything like that. And we want it to be able to hit other players. We don't want it to hit triggers and things that we only use for controlling gameplay state. And we don't want it to hit ourselves. So in order to make sure that this won't happen, we create another serialized field. And this is going to be a private layer mask. I will just call this mask. And this will allow us in Unity to control what we hit. And we simply put that in here. So I think this is the correct order. If not, we'll get an error. So we've simply hit something, and we know everything about what we've hit by using the hit variable here. So you can see if I do a dot there, we have the point we've hit, the normal that we've hit of the surface, the collider that we hit, the distance to the point we hit, and all that stuff. So that's a lot of useful information, and we can do a lot of stuff based on that information. Okay, so for now we can simply do a debug.log statement here saying that we hit and then plus hit dot collider dot name. Cool. So now I've saved that, and everything here should be working. And now when we hit back into Unity, we want to select our player and make sure that we fill in some of these settings. So we can expand our player here and drag in the camera. We can see that we now have the weapon here, and that's a Glock with a damage of 10 and a range of 100. And we have this mask. And for now we want to set that equal to everything. If we go in and test this now, there's a great chance that this will just hit our own player. But that's fine. We just want to make sure that this is working. So if we hit play and select LAN host and look down at the console here and then click, you can see we actually hit the floor prototype. That's great. So we didn't hit our player there. And you can see if I just shoot into the air, we don't hit a thing. And it's the same when we shoot at these cubes, because they don't actually have any colliders. So maybe we should actually just go ahead and quickly create some colliders for those. So simply select all three, and we can actually just add a box collider for all three simultaneously. So now that we have that in place, we can go ahead and hit play and maybe shoot some of those. So shoot one there, and you can see that it says down here what we've hit. So that's perfect. Don't worry, we'll do a mouse lock at some point. It's really annoying right now. It doesn't lock to the center of the screen, I know. Great. So now that we have that in place, we want to assign our player to a certain layer once we set him up, and all other players to another layer. This way, every local client will have a setup where their own local player is on one layer and all other remote clients or remote players on another layer. And this way, we can simply set the mask here to only hit remote players and not local player. So if that sounds weird, fine. But I'll just show you actually how easy this is. One thing I will go ahead and do is simply tag our player as player, because we're probably going to be needing that at some point, and it also just looks really clean. So under the layer here, we don't have enough layers to work with already. So let's go ahead and add a new one. We want to have a local player layer and a remote player layer. And of course, we could just go ahead and assign that in here. And we are going to do that for the local player. Yes, change children. But we want to assign it or change this to remote player through the player setup script. So if we double click this, we can see that we have this code that in the start method will check if we are not the local player, and then it wants to disable a bunch of components. And if we are, well, then we want to disable the scene camera. Well, we can simply use this to change the layer also. So first off, let's just organize this into a separate function. I mean the component disabling here. So we'll just make a void disable components, just so our start function won't get too crazy here. So just put that in there. That looks cleaner. And then here we'll simply call disable components. And then we'll make another method here, and we'll call that assign remote layer. And we'll call that in here. So if it's not a local player, then we want to assign it to the remote layer on this client. So, and in order to do this, all we have to do is specify the name of the remote layer. So we'll just make that a serialized field up here. So string remote layer name, and we'll default that to remote player. And then down here, we are calling that here. We can simply say that I believe layers are stored on the game object. So game object.layer, yep, equals layer mask dot layer to name, or name to layer. And in here, we'll simply put the layer, the remote layer name. There we go. So basically we have to write it. We can't just set it directly because GameObject.layer wants an index, so an integer value, because all layers are assigned numbers and they're just represented in the Unity editor by strings, but they are in fact numbers. And therefore we need to call this utility function that will take the string and convert it to the index that we want and then put that back into the GameObject.layer. So now that we have this in place, we should be able to see if we connect multiple clients that we are able to hit each other and that the layers assigned are correct. So let's try and build this by hitting Control B or Command B if you're on the Mac. And this should hopefully be working. So it's opening up there and we can start the game in Unity, hit LAN host, start the game here, hit LAN client. And if I just head into Unity here and have a look in the scene view, we have this one player. This is our local player. That's the one that spawned first on this client. And then we have the other remotely connected player, and you can see that's on the remote player layer. And of course, if we were able to inspect the properties for this player, we would see that the situation was reversed. Good. So if we now hit into Unity here, we should be able to hit each other here. So if I shoot him, that is not working. Oh, yeah, it is. It worked, but for some reason I also hit the floor there. I don't know, but it went through for some reason. Let's just have a look at that. That's kind of weird behavior. So it's registering twice here. Oh, that's because we are shooting for both players. Of course. I don't know what I was thinking there. So that's because we have to go in and disable the component. We'll look at that in a sec. But you can see that it says we hit the player there. And that's all that we need. So now that we know that this is working, what isn't working is that we don't have any checks inside of our PlayerShoot to see to make sure that we only do this for the local client. Because when we get the input down, we don't want to fire on other players' behalf, which was what we just did. So we could do a check in here saying that if we are not local player and all that, but instead, what I want to do is use the same method that we've done for other components, which is simply adding them to the components to disable array. So let's just expand that to one more and drag in the PlayerShoot. And that should be all. So now when we save this and build this and put that there and run this here, LAN host and here client, I'm just gonna go into Unity here and shoot the player. We'll see that there's only a debug.log statement being called here. What you will also notice if we go in here and shoot around, shoot the player, then shoot here and shoot over there, we've hit a bunch of things, this console.log or this console doesn't update. So currently we are only registering this shooting and the fact that we've hit something locally on the client. We need a way to send this information out to the server. And that's what we'll do next. So when we want to send this information about what we've hit and the fact that we've hit a player out to the server so that the server can distribute it among the clients, we need some kind of way of recognizing different players. And therefore I want to introduce the concept of a unique identifier, some kind of ID that will allow us to know what player belongs where. And it's actually very simple, because right now when we spawn a player in here, you can see that they're all called player clone. Well, when we attach a network identity object a component to an object, that's going to have a unique identifier already. This has an ID. It's just not showing anywhere. So for the sake of convenience, let's take this ID and let's add it to the player name. That way we can simply check for objects with a certain player name in order to tell them that they were hit or they should apply damage or whatever we want to do. So in order to do this, let's again go into our player setup script. And this is starting slowly to become a longer script. And in here, no matter if we were registered as a local player or not, we want to set the name of the player. So in order to do this, let's simply get a reference to the network identity component. And we want to simply do this without checking if it's there or anything, because whenever we have a network behavior, well, that requires that component. So we don't even need to type require component up here. That's kind of done already. So let's get a string ID and set that equal to get component of type network identity. And then we simply want to say dot net ID and close that off. And I think we should go ahead and combine this with the fact that it's a player. So let's simply type player plus and then get the net ID. And I want to have a space in here also. You could also create a variable up here for the name of the player, sort of say, other than the ID. But I think this is fine hard coding it here for now. In a future video, I want to keep track of what players are currently in the game and all that. Now that we have this string, we simply want to assign it to the object. So we can simply go in here and say transform.name equals _ID. And that's basically all we have to do. I mean, it's that easy. So let's create a void here, and we'll simply call this the register player. Because that's basically what we're doing. We are assigning him an ID to make him unique and therefore registering him in the scene. So register player. And later we'll register him to some kind of dictionary. And then we want to simply copy and paste those in there. So now when we hit play and select LAN host, you can see that he's registered as player 1. And the next one is going to be player 2. You get the system. Cool. So now inside of our PlayerShoot script, we can go ahead and call a method on the server and simply give it the ID. So this here is a local method, and therefore I want to mark it as client. So this is only called on the client and never on the server. But the next thing here is going to be what is called a command. So therefore we want to mark it as a command. And it's a good idea when having command functions, when naming command functions, to start them with a CMD, just to know that it's a command that we're working with. And commands are basically methods that are called only on the server. So this here is going to be player shot, or player has been shot, or tell server player is shot. You can call it whatever you want. I'm simply going to say player shot. And then we want to insert some kind of ID here. And inside of this command, all we do is we say debug.log, and then we would say ID plus has been shot. That's all we need to do here for now. Later we'll do damaging. So in here, if we've actually hit something, and we want to check if it's a player that we've hit, so if hit.tag hit.collider.tag is equal to player, we could do something like that. We could also check if the layer that the object resides on is equal to remote player. We can do all a bunch of stuff here, but I think we'll just check if it's if it has a tag of player. And We could of course not hardcore code this. I don't want this to show up in the inspector, but I think I will declare that up here. So let's just make this a private, and it's going to be a constant, and it's going to be a string, and we'll simply call this the player tag and set it equal to player like this. And then we can simply take that player tag and input it there. And then we want to call our command PlayerShot, and we want it to give hit.collider.name. There we go. Finally. So let me just run through this. So if we register some input, we shoot, and this is called on all local clients, but because we've made sure that the component is disabled for all other than the local client, it's only called on the client that is actually doing the shooting. And then we shoot out a ray, and if it hits, we check if it hit a player. And if it did, we call a method on the server called PlayerShot, where we give it the ID, which is also the name in the hierarchy, as an argument. And then here on this server, we'll print out that this certain player with this ID has been shot. So what you could also do here, if you wanted to then, let's say, remove that object or damage it in some way, is we could use GameObject.find and then insert the ID here, and that would give us the object so that we can then destroy it. So we could go in here and say, well, we want to destroy this GameObject.find, and that would kill off the player. But we're not going to do that because of two things. First off, we haven't talked about what happens when players die and all that, so simply calling this the destroy method wouldn't be a good idea. And also, GameObject.find is really slow, and therefore we are going to add this player dictionary later that will pair players with IDs and remove them when they disconnect and all that. So now that we've saved that, we have the player setup working, we have the player weapon, everything should be working. And if we just go ahead and hit play here, you can see that nothing is happening when we just shoot around. So let's go ahead and build this so that we can test it out with another client. And the cool thing that we should be seeing now is that when we hit a player here, it should throw a console log here also. So we have that working. We want to select host here and client here. And let's go ahead and shoot our player, shall we? And it's not updating for some reason. It's not updating in here either. So something is going on. I'm just gonna check what is wrong here, and then I'll get back to you in a second. Okay, so I found this really dumb mistake that I made, and you've probably known all along. But this, of course, doesn't want to be in quotation marks. This is just a variable. So let's make that player tag so that we don't search for a tag of player tag. That would just be stupid. So let's try this again. Remove that, build that, and finally it should be working. Hopefully, in some way. So let's select LAN host, let's select client, let's go over here and let's shoot our player. There we go. So it says player 1 has been shot, and player 1 is the editor client. And again, if I shift over here and shoot the other guy, it says player 2 has been shot. And you can see just how clean that is. Now the client knows, now the server knows, and therefore all clients have the ability to update their game state based on the fact that someone has been shot. So that's the end of this video. I hope you liked it, and I'll see you in the next one.